Hi students, in today's lesson we're going to be extending on the topic of function rules, and we're going to be looking at a topic called function notation today. So the definition, function notation is just another way of representing our output variable. So if you recall from the lesson last time, we have two different variables, one that represents input and one that represents output. And if you remember, we always associated x with our input and we associated y with our output value. So with function notation, it's basically another way of representing the output variable y. So I want to show you what function notation looks like. Function notation looks like this form right here. So you'll have a letter, and then in parentheses you would have the input variable. So if you were to read this out, you would read this out as f of x, or it's basically a function of x, meaning that x is our input variable. So whatever letter's out in front of the input variable is basically the name of the function. And then of course this expression is the resulting output of what we would get after we plug in for our input number. So just remember, f of x is just another way of representing the variable y. They're used interchangeably a lot of times. So let's talk about how do we evaluate functions using function notation. So here's an example. We're going to find f of 9 if f of x is equal to 5x minus 7. So you're probably wondering, what in the world does this mean right here? Well, f of 9 simply means that we're going to evaluate the function for the input value 9. So all we're doing is we're just going to plug 9 into our input variable x and then simplify the expression down. So f of 9 would look like this after we plug in our value for x. So 5 times 9 minus 7. And 5 times 9 gives us 45. 45 minus 7 gives us 38. So that would be our resulting output for this value that we were plugging in for the input. Let's try some practice problems out just to make some better sense out of how this works. So for the function f of x equals 2x squared minus 3, find the following. So what we're going to do is we're going to evaluate this function for 4 different values for our input. I'll do the first one as an example for you. So we're going to evaluate for f of negative 1. So f of negative 1 is going to equal, and basically we're going to take this expression and then replace our input variable with the value that we are evaluating for. So let's simplify this down. Negative 1 squared is the same thing as negative 1 times 1, or 1. And then 1 times 2 gives us 2. So 2 minus 3 gives us negative 1. So that would be our solution for the first problem. I'll do the second problem as another example for you step by step. So we're going to evaluate for f of 0. So f of 0 equals, I'm going to replace x with 0. So 2 times 0 squared minus 3. Well, 0 raised to any power is always going to be 0. 0 times 2 is 0. So 0 minus 3 simplifies down to negative 3. Now, if you would like to, pause the video right here and try these next 2 problems out on your own. And once you feel confident with it, hit the play button, then you can compare your work to the steps that I will model for you. So let's evaluate these problems down. So f of 3. So let's start off by showing our work. So f of 3 is equal to 2 times 3 squared minus 3. So 3 squared is 3 times 3, which is 9. So I'll add that extra step in because I do want to show you that I am using order of operations. 2 times 9 is 18. So 18 minus 3 gives us 15 as our solution. So let's try the last problem out. F of 0.5. So f of 0.5 is equal to 2 times 0.5 squared minus 3. Now, if we do 0.5 squared, that's going to give us a value of 2 times 0.25. 0.5 times 0.5 gives us the decimal value 0.25. So now, let's multiply together. 2 times 0.25 would be 0.5. 0.5 minus 3 is going to give us a negative result, and we're going to get negative 2.5 as our output. So there's some examples that I have worked out for you demonstrating how do we evaluate functions using function notation. So it's really nothing different from what we were doing before in the last lesson. Again, the only thing that we're doing is we're just rewriting the variable y differently using this notation right here. I'm going to pause the video right here, and we're going to take a look at a few more examples.